Okay, good. Okay, so we're looking at number 5, find the domain, letter F on 1.2 of our notes. And like we were looking at domain yesterday, we have to ask ourselves, like, what is a problem? What doesn't get to be included in my domain? So if I'm looking at the equation 3x to the third over x squared minus 4, what would a problem be here? What would a problem be? 2. Why would 2 be a problem? It would equal 4, and 4 minus 4 would be 0. I cannot have it equal 0. What else would be a problem? I can think of another number that would make this a problem. -2. -2 squared is 4, and 4 minus 4 is a problem. So +2 and -2. If I want to draw my number line like we were drawing yesterday, I'm going to have a hole at -2, and I'm going to have a hole at +2, but I can fill in everything else from there. I can go less than, I can go in between, and I can go greater than. So I'm going to have 3 intervals right here. Who said wait? No, wait. Okay. So I'm going to write my 3 intervals. Anyone want to help me? Good. 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 All parentheses. So that's my interval notation of all the things that work in my domain. -2 doesn't work, so I had to skip it, and +2 doesn't work, so I have to skip it. All right, now I have to look at the next one. This is basically the same problem, but it says x to the third plus 4. Or sorry, x squared plus 4. What would make x squared plus 4 equal 0? -2 squared would be 4. Would there be one? No. Why not? I'm always going to get a positive number right there. There's no way I'm going to be able to get that to be -4. So if I'm always going to have a positive +4, I'm always going to have a fine answer down there. If I have no restrictions or no problems, I'm going to say that it's -infinity to infinity. That's a fine domain. No problems. All right, how are we doing with that? Okay. All right, now we're going to talk about if it's a function. So vertical line test, is it a function or is it not? Bless you. The first 2 are just graphs. Remember vertical line test, we just draw vertical lines. If it only crosses my graph once, then we're cool. This first one, that's a function. You cool with that? What about the second one? That one's not a function. I have 2 places where any vertical line would cross my function. So this one's a nope. Vertical line test is the easy part. It gets a little bit harder when I give you an equation and I make you have to find it. So this first one says a y squared equals x plus 2. How do you get y by itself? Square root. And when I square root, what also has to follow with? And plus or minus. I wrote it a little prematurely. Plus or minus. That means whatever I plug in, I'm going to have a plus and a minus answer for that. Let's say I plugged in 2. X equals 2. 2 plus 2 would be 4. So I'm going to do plus or minus the square root of 4. Well, the square root of 4 is 2, so I'm going to do plus or minus 2. If I plug in a positive 2, I could either get out a positive 2 or I could get out a -2. Am I allowed to have two different y's go with my x? If I drew like a mapping diagram like I drew yesterday, could I have two different y's for my 1x? No, only y's are allowed to repeat. I can't have my x repeats. When that happens, I get like the circle-like graph because I have in one x value at 2, I have a value at +2 and I have a value at -2, and that's a problem. The minute I actually saw this square on my y, I knew I had a problem because I knew I was going to have two values. If you have a y square, I can automatically say it is not going to be a function. Are we okay with that? All right, next one. X equals 12 minus y. Ooh, what do I need to do there? Get y alone, move the 12. I think that's what I'm hearing from you guys. I'm going to get negative x plus 12 equals y. Is that okay? Does anyone know what kind of function that is? What do you say, Patrick? Linear. It's going to be a line. This makes a line. And that, I know a line is a function. So that is okay. This is yes. So we did it with the graph, yes or no, and then we did it with our equations. Another thing is this y was not squared, so I know that I'm only going to get one y out when I get in an x. Only one y for the x. All right, thoughts, concerns, comments? Exactly. Even if it's on the other side of the anytime there's a y square, we have a problem. Wait, why? Because once you square root it, you're going to get a plus or minus. And that's where I get two answers, and that's wrong. The plus or minus is the problem. So then it's like 2x for 1y. It's like 2 y's for 1x, and then you can't have that. Okay, you need your calculator for this next one. This one is discontinuity. Let's actually refresh our brains so I don't get as frustrated as I got with my other class. Remember on Monday I taught you about continuous and discontinuous? Oh, Haley. Continuous is where you don't have to pick up your pencil. It is all fine. You can do it all in one foul swoop. There's 3 types of discontinuity. One is where it looks normal except there's a hole. Jump is where I do my normal function, but then it's like I cut it and then I like retaped it somewhere above it. And the non-removable is where there's no way for me to fix this discontinuity at all. It's a little bit before this. Wrong direction, Patrick. Mm-hmm. One more flip, maybe. Perfect. Okay, so I'm going to tell you right now, these are discontinuous. What we're going to do, though, is we're going to graph them and see how are they discontinuous, which one are they? Are they removable, jump, or non-removable? Okay, so let's go back to our equations, and I'm going to graph them in my calculator. So I'm going back here. I'm going to say x to the third plus x divided by x. I grew up with a calculator that wasn't very smart, so I put parentheses around everything. You might be okay if you don't have parentheses around everything, but I would be careful in case you need them. Okay, do you put that in your calculator? Did you guys graph it? I'm sure I'm on a normal standard. Okay, good. Now, this doesn't look discontinuous, right? It looks just like a parabola. However, if you look back at the algebraic equation, we just practiced finding domain for a long time, right? What number would not be in my domain? It's just a normal x. What number would not be in my domain? What'd you say? Well, looking at my equation in orange, I think I have a problem. Okay, what'd you say? It's a normal x, just a regular x, positive x. It can't be 0 where, Ellie? It can't be 0 in the denominator. Based on my equation, I have a denominator and it can't be 0 in the denominator. And if I plugged a 0 in, it would be a problem. We can't see this from my Zoom, and I honestly think your calculator is so smart, even if you zoomed in, you wouldn't find the hole, because it's exactly at 3. It's not at like 3 to whatever. It's exactly right there, or it's exactly there at 0. But let me show you a trick. If I go to second trace and I press value, I can type in any x and it'll tell me what its y is. So I'm going to press that, and I'm going to say, okay, if I plug in 0, what would my y be? It's nothing. There's nothing there. So is there a y value when I plug in 0? No. That means that there is a hole, and I call it removable discontinuity. Are we seeing what I'm seeing? At 0. This is what it looks like in a more exaggerated form. Or I guess it should be up a little bit. Just let it be. I guess I'll make this. But there's a hole at 0, and that means it's a removable, bless you, discontinuity. Because if I look at my equation, yeah, because looking at the graph, I couldn't really tell that there's a problem. But when I look at the equation, I know that there's a problem. All right, shall we try the next one? Yes, Haley? Do you have your stat plot on? Go to y equals. Yep, that happens here too. We can put the stat plot on, so we're going to just scroll up on it, and then we're going to click yes, and then that's now that being said, we have weird parentheses. So what this reads it as is x to the third plus x divided by x. I want to throw parentheses in here. So if I put all that parentheses, and that means all that now. So whenever I have a fraction in my top in my fraction part, I would put parentheses around everything on top and on bottom. And that's what I'm about to do for the next one. So the next one is, oh no, did I lose? Oh no, my Zoom's at the bottom. Ooh, thought I lost it. Okay. The next one says x divided by x minus 2. So when I put that into my calculator, I'm going to put x and then divided by, and since I've got more than one thing on the bottom, I'm going to put parentheses around my x minus 2. And then I'm going to graph that. This looks just like one that was in our notes. Does anyone know what this one's called? That's the function. What kind of discontinuity is it? Infinite or non-removable. Very good. You can call it either one. And I'm just going to draw a picture in case I go back to my notes later and I don't know what I was thinking. It looks like this. There's no way for me to like pick up a point and like fill in that spot, or no way for me to like carry down like a jump discontinuity. Like I can't fix this graph and make it all continuous. All right, how are we doing? Good? Shall we carry on? Okay, next problem. I don't think I need the calculator for any of these next ones. So I'm going to make this big. Okay, so this says even, odd, or neither. We're doing symmetry here. So we're thinking back to the symmetry. Ooh. And yesterday at the beginning of the page in front of it, we did symmetry and we said that if f of negative x is equal to f of x, then it's even. And if f of negative x is equal to negative f of x, then it's odd. So we're going to put that into practice. What you need to do is we're going to plug in negative x into all my equations. If it equals the function you started with. Whoa, what is happening here? Notability, what are you doing? Nothing good. This app is on my last nerve, you guys. If it's equal to the function you started with, then it's even. If we plug in x to the negative first, though, and we get negative the function we started with, then it's odd. And if we don't get either of those things, then it's neither or neither or none or whatever you want to call it. But we're going to start by plugging in negative x. So let's just do a couple and kind of see what's going on. How far? Oh, yes. Symmetry is plug in negative x, and then you get two answers. Either you'll get the function you started with, and then that means it's even, or you'll get negative the function you started with, and that means it's odd. Mm-hmm. It's going to be even. Oh, negative the function you started with. Okay. So letter A, this doesn't really make sense in words, so let's do a couple examples and then you'll kind of get it. So the first one is f of x is x to the fourth. Okay, what if I plugged in negative x to the fourth? What would I get there? Positive. I don't know what x to the fourth is, so I still have to keep my fourth there, but negative x raised to the fourth will end up being a positive number. This is the function I started with. This is the function I got when I plugged it in. Are those the same? Those are the same. This is an even function. Okay, let's do another one. Now I've got square root of x squared plus 2. So I'm going to do square root of negative x squared plus 2. What's negative x squared? Positive, good. Positive x squared plus 2 under the radical. That's as simple as it gets. This is the equation this is the function I started with. This is the function I got. Are those the same or is it negative? The same. So what symmetry do I have? Even. Hanging in there so far? Okay, I've done 2 even, so it looks like we're on the trend for something different. Let's see what happens. 2x to the third minus 3x. So I'm going to plug in negative x and negative x. A mistake we sometimes make is you only plug in negative x for the first x you see. If there's multiple x's, you have to plug x in for every single thing you see. So I plug negative x in for all of them, and now I'm going to simplify. Negative x to the third is positive or negative? Negative. So I'm going to have negative 2x to the third, and then negative 3 times negative x is going to be positive 3x. Okay, this is what I started with. This is what I got. Why is it odd, Gabby? Good. And then also, so this became negative and then this became positive. If I had just multiplied this whole equation by -1, that would be the exact same thing I just now got. Those two are equal to each other. That's what makes it odd. Sometimes you may need to check by multiplying that -1 through, and that's okay. Another one. Let's go. 1 over x. Let's plug in -x. I've got 1 over -x. Well, there's not much to do here, right? That's just the same thing as -1 over x. If this is where I started and this is what I got, even or odd or neither? Odd. We doing okay with this? Yeah? Okay. You guys are just as quiet as the other class, but you look more involved. We all doing okay?
So just plug in minus x or negative x. Because it seems like it's adding negative.
It is negative. You can call it minus or negative. We're not going to minus x from anything. It's just we're going to make the x a negative number.
Oh, okay.
Okay. Good. Sound like an aha thing. You still back there, okay?
Yeah.
Okay, you paused for a second. I was like, okay. Yeah. Sometimes I say minus and I just mean negative, so I'm sorry if I said that funny. So yeah, we're just making them all negative, and then we're kind of seeing how the signs carry through. Let's do one last one. Let's see what goes on here. So I've got -x squared, so I'm going to do negative times -x squared plus 0.03 times -x plus 5. Okay, -x squared is going to be +x squared, but times a negative will be still -x squared. 0.03 times -x will be -0.03x, and then the 5 doesn't change. Is this going to be even, odd, or none? Why is this one none? Only one changed. So you could think of it one of two ways. You could say, okay, well, two of them are the same. The 5 and then that -x squared are the same, but that 0.03 is not the same as what it was. Or you can think about one of them flipped, but the other two didn't flip. You need either all of it to be the same or all of it to be negative. You don't get to just pick and choose. This one does not have symmetry. This one has no symmetry or none or neither or whatever you want to call it. Yes. All right. We doing okay? Okay, now we're doing asymptotes. Asymptotes come from a reciprocal function. And a reciprocal function looks something like this. I believe this is the parent function, but maybe it's flipped. I can't remember. There are always asymptotes here. There's two asymptotes. There's a horizontal one at y equals 0, and there's a vertical one at x equals 0. We're going to do vertical asymptotes first because I think that they're easier. So vertical asymptotes are always x equals something, and x equals the number we find to be my vertical asymptote we get by setting the denominator equal to 0. Whatever will make my denominator 0 is not included in my domain, so it's physically that asymptote that I never touch and I never cross and I don't get to use. Okay, so all we're doing is looking at the denominator. I'm not even going to tell you what horizontal asymptote is until we find all these vertical asymptotes, okay? So let's jump over to our example problems. I'm going to make a little grid so I can keep it all nice and neat. So I'm going to do vertical asymptotes here. Again, I'm just going to set my denominator equal to 0. So in the first one, letter A, my denominator is x plus 1. So x plus 1 equals 0. X equals -1. That's it. That's your vertical asymptote. Let's look at letter B. My denominator there is x plus 3. So I set that equal to 0. Minus 3 from both sides. Your vertical asymptote is x equals -3. We doing okay? All right, letter C. Ooh, what's my denominator on letter C? 1. I don't need to set 1 equal to 0 because that will never be true. If it doesn't have a denominator, there is no vertical asymptote. There is none. All right, letter D. All right, we're going to set my denominator equal to 0. X squared plus 1 equals 0. Minus 1 from both sides. Square root. Ooh. Ooh, yuck. I don't even care about the numerator. I do care that I've got a radical -1. Is that a real number? No, that's by definition an imaginary number. There is no need to worry about imaginary numbers here because I can't go to my graph and be like, oh, look at me, I'm putting a vertical asymptote through I. Oh, now I'm doing 1 through -I. There's nowhere on the graph that there's I or -I. So I'm going to say that there is no vertical asymptote here. So I did not even need to do that work. This one's a none too. All right, what about letter E? What do you notice about E? It doesn't get to cancel out because it's a -1 on top and a +1 on bottom. What else do we notice about E? It's the same as the last problem. Do I even need to do any of that work out? No, I'm just going to write none. I know that there's not going to be a vertical asymptote. All right, 2 more, and then we got to learn about horizontal asymptotes. In letter F, my denominator is x plus 3. So set that equal to 0. X equals -3. Cool, that was easy. Oh, and then the last one's a quadratic. Oh, that's fun. We haven't done one of those for a minute. X squared minus 5x plus 4 equals 0. Okay, factor. X minus 1, x minus 4. So x equals +1 and +4. In this one, I have 2 vertical asymptotes because I have 2 numbers that do not work in my denominator. You're allowed to have more than 1 vertical asymptote, and that's okay. It just depends on what's given to you. So this was an example where I have 2 vertical asymptotes. All right, adjust. Now we're going to do horizontal asymptotes. My seniors last year kept calling these Ha's. Do you guys call horizontal asymptotes Ha's? It's like, what? No, I don't know. I thought they must have gotten them from Miss Ludington and Miss Hollis, but I guess not. So they just called it Ha's for no reason then. That's weird. Okay, horizontal asymptotes. There are 3 different choices. Well, classic. 10%. Oh, I can make it. Okay. There are 3 options. The first one is that the exponent on bottom is bigger than the one on top. If that is the case, you will always have a horizontal asymptote of y equals 1. So if there's no x's on top and an x on bottom, that means that the bottom is bigger than the one on top. If you had like an x squared on top and an x to the 5th on the bottom, that's bigger on bottom. So that means it's this example. Okay. Smaller on top means y equals 0. What if they're the same exponent? If they're the same exponent, then we go to look at their coefficients. And I just know that my y will equal whatever the fraction of their coefficients is. So I'm just physically writing coefficients here because I don't know what that is in each case. Am I ringing some bells? Maybe yes, no? Okay. I know you've learned this, whether you remember it or not. I know you've learned this. Because when I taught Algebra 2 at a lower school than this, I taught them this. So I know you guys have learned it. The third option is if my exponent on top is bigger than the one on bottom. If that is the case, you will not have a horizontal asymptote. You're going to have a slant asymptote. You're going to have like an actual line. So you're going to have a slant or a line, and you're going to get that by doing the long division of your polynomials. You guys remember polynomial division? Yeah, we're going to hit it a little bit harder in another like lesson or two, but I am going to preview it today. So the first thing we have to do is we have to look at the exponents and decide which three of these cases it is, and then we just have to follow that road, whichever one it is. Okay. I'm going to zoom out a little bit so we can look at letter A. Letter A says x over x plus 1. Is my exponent smaller on top, the same, or bigger than on bottom? Exponent? Same. Exponent, I'm only looking at my x's. So those are both x. They're the same. So now I look at their coefficients. What's the coefficient? Good, 1 and 1. If there's no number written there, we assume it's a 1. So my y-intercept, or sorry, my horizontal asymptote will be y equals 1. Since their exponents are the same, we look at their coefficient. Let's look at letter B. What do we have going on here? Is the exponent on top smaller, the same, or bigger than the one on bottom? The exponent is the same. Coefficient's bigger. Coefficient is bigger. I get messed up about them too, so I'm trying to be really careful about what I say so I don't lead you down the wrong path. Their exponents are both 1, so that means that I look at their coefficients. It's going to be 2 over 1, or just y equals 2. All right, what about letter C? Second, guys. Does this look like the other two examples we just did? No, because it's not a fraction. Does it get an asymptote? No, this is y equals x squared. There are no asymptotes in a quadratic. None. What one would work? All right, the next one. I've got 4, and I have x squared. What's technically the exponent of my x in the numerator here? Do you see any x in the numerator? Technically x to the 0. That's smaller than the one on bottom. So I'm looking at example 1. My horizontal asymptote will be y equals 0. Do I need to explain that some more? Okay, I'm gonna keep rolling then. Letter E, what do I got going on there? Their exponents are both 2, so I go to look at their coefficient, and their coefficients are 1. Ooh, F is one of those funny ones. F is one of the ones where it's bigger on top than it is on bottom. Let's do a long division. You do It's going to end up being a similar answer here, but I can't promise that's going to happen every time. So I am going to do a log division. I'm going to have to do x plus 3 on the outside, and underneath I'm going to divide x squared, and I'm going to say plus 0x minus 9. If you forget the 0x, you're not going to get the right answer. You're going to have a little bit of a hard time. When I do long division, I ask myself, okay, what do I need to multiply by x in order to get x squared? The answer is x. X times x gives you x squared. Don't forget to distribute that to the 3, so I have plus 3 here as well. Just like when you did long division as a second grader. I think that's when you learned long division. Fourth grader? I don't know. You have to minus, and I have to switch all my signs. The x squares cancel, and I'm left with negative 3x. Carry down your negative 9. Now I ask myself, okay, now what multiplies by x? Because it was negative in my problem. Now what do I multiply times x to get negative 3x? Negative 3. Multiply negative 3x. Negative 3 times positive 3 is negative 9. Ooh, this is going to work out nicely. I change my signs. Oh, the 3's and the 9's cancel. Sometimes we won't get them nicely canceled, and we just ignore the remainder, and I just give whatever equation is right here. But that didn't have to happen there. Again, we will hit this harder in another lesson. So if you're like, I like hung on for this, but like I couldn't do this on my own, you'll be okay. This will not be on the, long division will not be on the quiz on Friday. Okay, so that one, my asymptote is not just a number, it's going to be y equals x minus 3. That line is the asymptote. All right, and then last one. Oh, it's an easy one. My exponents are what? Exponents are the same, so I look to my coefficients, which makes my y horizontal asymptote 1. Good. Okay. C was none. Okay, what I did in my other class for the last couple minutes, and I'd be happy to do this with you guys, is as I told you at the beginning, your BFFs, you need to know name, graph, and equation. You don't have to fill all of these things in for Friday, but we will need to fill them in eventually. If you want me to, I can walk through one with you so that you don't have to do it all on your own later. You want me to do one of those? Is there one that is like what you really want me to do? Yeah. You need to look at your book and you need to find what all of them are. So I have all of the names are the first line. The identity function, the squaring function, the cubing function. You need to find those and then figure out which equation goes with it and then what graph goes with it. All of them. Mm-hmm. They're all parent functions, so you've seen them before. Some of them you've worked with more or less than others. But like since we're in pre-cal, I need to know that like if I say the square root function, you know what I'm talking about. So like we were looking at the square root function actually last class, and I can like kind of start walking through that one with you. It's the middle on the second page, or the second side of this. And that equation is y equals radical x or square root of x. So that's the equation you will need to know for Friday. That's the name you need to know for Friday. And the graph is basically a sideways parabola, but since it's a function, it doesn't have the bottom part. It doesn't have any negative numbers. It's just all positive. Think about it. If I were to plug in x's, we'll see what y's we get out. If I was to plug in 0, I'd get out 0. So I have a point at 0, 0. I can't plug any negative x's in or else I'd get i's, and I can't graph that. So that's not going to happen. Next, I'll try 1. Okay. Oh, nice. The square root of 1, that's a real number. That's positive 1. So if I plug in an x equals 1, then I get out a y equals 1. Now, I'm not going to plug in 2 because I don't know what the square root of 2 is. I do know what the square root of 4 is. Let's try that one. Square root of 4 is 2. So I plugged in 4, that was your x. 1, 2, 3, 4, and then I got out 2, which is my y. The only other one I would get is 9 and 3, and that would make my graph look like that sideways parabola. Oh, are you going somewhere? No. Oh, okay. You got me really scared with putting your backpack on. No. Didn't know I was keeping you from something. All right. Domain is my x's. What is my restriction on my x's? What's my smallest x you see? 0. And then what's the biggest x we see? Infinity. We got an arrow. Good. We have no negative x's. We also have no negative y's. So my range is also 0, positive infinity. It's not moving as fast as my x's, but it's still going to go on and on forever. Is this continuous? Yep, this is continuous. We'll skip increasing and decreasing for a second. Oh, we'll skip the rest, I guess. But this is what we have to do for all of them.
Lord, I surrender myself to you. Take care of everything. In the name of the Father, Son, Holy Spirit. Hail Mary,
Full of grace, the Lord is with you.